function, a limit given like this: limit x approaches 0, e power x minus e power negative x divided by x. Evaluate this function. Now let's see how to do this. Let's go ahead and do the direct substitution first and see what we are getting. If I do the direct substitution for this one, this is going to be e power 0 minus e power negative 0 is still 0. So this is going to be e power 0 again divided by 0. E power 0 is 1, and 1 minus 1 divided by 0. That gives us 0 by 0. That's indeterminate. We cannot have this answer. So we have to do something else. Now I'm going to remove this one and see what we can do here. If you look at my last video, I introduced L'Hopital rule. Like whenever we have exponential function, we can use the L'Hopital rule. L'Hopital rule is basically when we have an exponential, like for example, let's say a power u, and if you take the derivative of that one, you can express that one as a power u times u prime times ln of a. Right? This is the expression of L'Hopital rule. Now we can go ahead and apply that one here and see. Let's see what we get. So if I do that one for this one, let's do that one for e power x first. I take the e power x here and I take the derivative d by dx. Okay, if I take the derivative first, we are going to have a power u as it is, so e power x remains the same, and I take the power and take the derivative of that one. So here the power is x, and if I take the derivative of that x is a constant number, so if you take the derivative of that one, that's going to be just 1. And ln of a, ln, here e is our a value, and we have ln e. And again, e power x remains the same, 1, and ln e is equal to 1. So this is going to be 1 again. So finally we get e power x. Now let's do the same thing for the e power negative x. If I take the derivative of e power negative x, e power negative x remains the same at first, and then we take the derivative of negative x after that. Derivative of a negative constant value is going to be negative 1, and then ln of a is e here, so this is going to be ln e, and ln e is 1, so this is going to be e power negative x times minus 1 times 1, and that's going to give us negative e power negative x. Now we can go ahead and substitute this one in the equation. So we have to keep on writing limit x approaches 0 until we substitute the 0. So I'm going to keep on writing that. Limit x approaches 0, e power, the derivative of e power, we are taking derivative top and bottom, okay, d by dx, and we already took the derivative of e power x, that's e power x, so we are going to have e power x right here, and then derivative of e power minus x is minus e power negative x, and in the denominator we have x, that's a constant value. If you take the derivative, that's going to be just 1. So we can neglect that one, and let's express this one in a better way. This one, limit x approaches 0, that's going to be e power x plus, because minus minus plus, so plus e power negative x. Now you can go ahead and plug 0 for the x values, so this is going to be e power 0 plus e power negative 0, that's 0 again. So e power 0 is 1, so this is going to be 1 plus 1, that's equal to 2. So the final answer is 2. Now to confirm this answer, you can always go ahead and take a value that's closer to 0 and see if you are getting 2. Now let's go ahead and do that. So I'm going to erase this one. Let's take a value that's close to 0. Let's take 0.1 and substitute in this equation. If I take 0.1, this is going to be e power 0.1 minus e power negative 0.1 divided by 0.1, and if you calculate this one using calculator, you're going to get 2.003335, and you can see this is approximately equal to 2, so we don't have to actually take another value to see that. We can already see that. and that's our final answer. 2 is our final answer. That's it for this video, guys. Thanks for watching. Don't forget to subscribe. See you guys on my next video.